Good morning, everyone. Welcome to today's, we have echo. Thank you, Karen. Welcome to today's workshop on analyzing longitudinal diary data. We have two of the world's leading experts here today, Professor Niall Bolger from Columbia and Dr. J.P. Laurenceau from the University of Delaware. It just so happens Niall and I go way, way back, and the only reason that I know anything about diary data and that I've used diary data in my research over the years is because I was a postdoc at the University of Michigan more years ago than I'm willing to admit. Maybe Niall will. When Niall was a postdoc there, and there were two postdocs that year, Niall and Anita DeLongis, who were using diary data, and it was when it was new, really.
It's pretty new, yeah.
Yeah, we didn't know that much about it. So I kind of got this great insight into this method that existed and how it's so perfect for certain kinds of research questions. So I feel like I was very fortunate to be there for lots of reasons, including there were people like Niall there, but also because I got to learn about diary data. So I want to give a shout out to a couple people before we get started, and I want to just jump right into it. I want to thank Rita Stramel for handling all the logistics for today. And I especially want to thank Hewan Che for organizing the entire workshop and working relentlessly to really think through what it is we need to know and how we're going to organize it. And you'll be hearing from her in just a second. So thank you for doing that. So welcome everyone in the room and attending by Zoom, and we will get started. So, Hewan.
Thank you, Deb, for the kind introduction. Hi, everyone. My name is Hewan, and I'm a postdoc here at PRC. So welcome. Thank you very much for attending. And I just wanted to, before we hear from our amazing speakers, I just wanted to give you a heads up that we will be taking Q&A for discussion Q&A after the two presentations, so please save your questions until then. But if you have any clarification questions that you wanted to ask, the speakers have agreed to take some time to take your clarification questions. So please keep that in mind. And also for those who are on Zoom, please enter your questions on the Zoom chat, and we'll be monitoring it, and we'll bring it up during the Q&A session. So without further ado, I would like to introduce you to our first speaker of the day, Dr. J.P. Laurenceau. He is currently a professor at the Department of Psychological and Brain Sciences at the University of Delaware. And he will give us his talk on Introduction to Longitudinal Dyadic Data Analysis. So please give him a big round of applause.
Thanks very much. Oh, let me see. Let me move over here. I think this will be good. Okay, so thank you so much for the introduction. Thanks, Deb, for inviting us out here. This is a great opportunity. My first time at UT, and I got to watch the basketball game yesterday, actually. I'm sorry about what happened, but you know, it was great. Anyway, so this is going to be a little different than what was advertised. We're going to change this up a little bit, if that's all right. So the title of this talk, and it's actually in two pieces. First piece mine, second piece will be Niall's. Actor-partner interdependence model, distinguishability, temporal processes, and heterogeneity. So it's going to be a little bit of a different order of presenting the material than I think what was advertised, but we hope we'll still be able to get to what people are interested in, and what I think the HARP team is also interested in too. So here's a little bit of a roadmap for what we're going to be covering today. So first is, we're going to talk about the actor-partner interdependence model, because it's one of the most studied dyadic causal models that exist out there in the literature. Causal, we use the word causal here in the sense that we're studying processes where we believe that there are causes that are taking place in relationship life such that we should be able to pick them up with particular kinds of temporal designs, and in particular the intensive longitudinal design that we're going to be talking about in the second part of the talk. So the first part is going to be focusing on the cross-sectional between couples actor-partner interdependence model. We'll focus on distinguishable dyads, and then we'll focus on indistinguishable dyads and what you have to do to be able to cover those kinds of couples. And then the second part of the talk, that will be Niall's part, will extend to intensive longitudinal, so it'll be within couples, moving from between couples to within couple processes. First focusing on distinguishable dyads, and then what we think would be the direction to be able to, what we think is a direction for addressing indistinguishability in these same kind of dyads. The second part of the talk uses an example that came from our book. We have a dyadic chapter in the book, so there's more detail in there about the particular example. And we also have code for actually several examples of analysis of diary data, essentially. Okay, so to move into this first topic, we're going to start with an overview of a particular data set that I'm going to use as a motivating data set called the FLASHY project that came from the National Cancer Institute. So flashy facts in a flash. Here we go. This is a one-time cross-sectional survey. It's a United States panel of teens and parents. It was web-based. There are two modules, a diet-focused module and a physical activity module. We're going to be focused on the diet-focused variables. Dyads are going to be the parent or the primary caregiver and their adolescent child. So these are the dyads that we'll be focusing on. These are distinguishable. The data were collected between April and October of 2014, and it was all funded by the National Cancer Institute. And if you want to be able to access some of these data and actually work with them, you can go actually to the website and be able to download what they have available. Now, some variables were measured in the same way for both the parents and the teens. In particular, fruit and vegetable consumption is an outcome that we're going to focus on. And then efficacy for eating fruits and vegetables is going to be another variable that was collected on both parents and teens that we'll be focusing on. And of course, some variables were measured differently, like parental control. In total, there are 1,646 dyads that completed the diet survey part of this project. So as I mentioned, there are two kinds of dyads that we need to be focusing on when we do dyadic research. The first is the distinguishable dyad, where there's some feature, at least that on the surface, can allow the members of the couple to be distinguished. So heterosexual couples might have a male and female partner, mother-child relationship. Those are examples of distinguishable. To measure non-independence, or how correlated the partners are in this kind of a context, we use a Pearson correlation to be able to do that. The second kind of dyad is non-distinguishable. So this is where we have same-sex friendships, identical twins, gay couples, that sort of thing. And non-independence in that context is measured by using something called the intra-class correlation. So I'm going to show you what the data set looks like. It's a small version of the data set that we're calling Flashy Small. And it's going to be set up in what's called a wide format. So this is where parents and teens have different variables, such as PFT veg for parents' fruit and vegetable consumption. We have TFT veg for teens' fruit and vegetable consumption. And in this particular piece of the data set, we have 1,486 parent teen dyads. So basically, parents and teens are going to have separate variables and their own columns of data in the data set. And this is what it looks like. So parent vegetable consumption, teen vegetable consumption. This is apparent efficacy for eating fruits and vegetables, teens efficacy for eating fruits and vegetables. This is the centered versions of these two predictors that we're going to be using. And then we won't be using these, but this indicates whether the parent is a female or not, and the teen, whether the teen is a female or not. Here's the outcome, just to give a little bit of information about the outcome. So for the parents, this is fruit and vegetable consumption. We took the original scale and put it on a 0 to 10 scale to make it more, make it easier in terms of interpretation of the modeling. So we have a nice kind of, what looks like, fairly normal distribution here for both the parents as well as the teen. And here's the predictor that we're going to be focusing on, efficacy for eating fruits and vegetables. So both the parents and the teens answered this same exact question. I feel confident in my ability to eat fruits and vegetables every day. And we also rescaled this variable so that it goes from 0 to 10. So both the outcome is 0 to 10, the predictors go from 0 to 10. And here is the basic actor-partner interdependence model. First, I think published in 1996 by David Kenny. So we have the fruit and vegetable outcome for the teen, fruit and vegetable outcome for the parent. We have efficacy for the teen and efficacy for the parent as predictors. And when the same partner's score outcome is regressed onto the same partner's predictor, that's called an actor effect. So we have a teen actor effect. We also have a parent actor effect. And then when we regress one partner's outcome onto the other partner's predictor, that's called a partner effect. So we have here a teen partner effect. TP means teen outcome regressed on the parent outcome. And then we have partner effect, PT, parent outcome regressed on the teen outcome. So this is the basic actor-partner APEM model, as it's called. And this is for distinguishable because now we have these roles, the parent and the teen roles, that are really important distinguishing features of this particular kind of couple. Here it is in equation format. So basically we have the outcome of the teen, it's regressed onto the teen's predictor. So that gives us an actor effect. The outcome of the teen regressed onto the parent's predictor, so that gives us a partner effect, excuse me. And then there's going to be a residual. We have the same situation actually in terms of the outcomes of the parent, regressed on the parent's own predictor as well as the teen's predictor. Okay, here is a breakdown of the parameters that are being estimated in this model. And we're going to be using a structural equation modeling approach to doing this kind of analyses. So in total, there are 14 parameters that are being estimated in this model. This model is a saturated model, so there are no degrees of freedom in this particular model. So on the X side of things, there are 5 parameters. They're going to be the mean and variance of the teen predictor, the mean and variance of the parent predictor, and then the covariance of the two predictors. So that's a total of 5 parameters on the X side. On the Y side, we're going to have 2 actor effects, 2 partner effects. We're going to have an intercept for the Y outcome for the teen, an intercept for the Y outcome for the parent. We're going to have a residual for the teen, residual for the parent, and then a covariance between the residuals that picks up residual non-independence for a total of 9 parameters. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Add those together, we get 14 parameters. So this is the basic kind of SEM conceptualization of the actor-partner interdependence model. so we have to estimate all of these parameters separately to be able to basically get results for our distinguishable dyads. Here's, I apologize for how small this might be, but we wanted to give you a flavor of the syntax that you need to use in a structural equation modeling package called M+, where you see here that we're regressing the teens fruit and vegetable consumption on the teens predictor and the parents predictor. Parent fruit and vegetable consumption is regressed on the parent predictor and the teen predictor. And all of these different terms here, the with statement here for the residual covariance, the covariance of the predictors themselves, and then the variance and the means of the predictors are specified here. And this is repeated here because we're using some labeling here to be able to do some interesting tests. So we can do things like test whether the actor effects are different between the parents and the teens. We can test whether the partner effects are different between the parents and the teens. We can test whether just the mean level of vegetable consumption is different for the parents and the teen. So once we estimate this model, here are the standardized estimates that we get, and doing this as a distinguishable case. So we have a pretty moderate size set of actor effects, that for the teen and also for the parent. We have everything is, by the way, statistically significant because there's 1,400 some odd couples here, and so really we're looking more at the patterns than we are about anything about statistical significance. So we have smaller partner effects that are being shown here. R squared is about 20% for the teens outcome and is about 13% for the parents' vegetable and fruit and vegetable consumption outcome. This is the residual covariance that's left over. And so this is the basic results from a distinguishable dyads analysis using the APIM. Now let's move to indistinguishable dyads. So what do we have to do to be able to adjust the model to be able to handle indistinguishable dyads? So here, instead of having teen and parent, we have like partner 1 and we have partner 2. We have Y for partner 1, X for partner 1, Y for partner 2, X for partner 2. And now what happens is we have to constrain the actor effects to be equivalent to each other, and we constrain the partner effects to be equivalent to each other. But in addition to that, we also need to constrain the means on the predictors to be equivalent to each other. We need to constrain the intercepts for the two outcomes to be equivalent to one another. We have to constrain the residual variances to be equivalent to one another, and we can estimate this residual covariance here. So on the X side, we have 3 parameters that we're actually estimating. On the Y side, we have a total of 5 parameters. 5 parameters for a total of 8 parameters. And let's see. Yeah, this is the basic the basic model for doing this with indistinguishable dyads. Here's the M+ syntax for doing this. This is just highlighting where the constraints were set up. So this is where the X variable, the variability of the X variable was set to be equivalent. The means of the X variable set to be equivalent. And then actor and partner effects are made equivalent here in this statement. And then finally, the intercepts of the two parent and vegetable, and fruit and vegetable consumption outcomes are set to be equivalent. And then the residual variance is also set to be equivalent for those two outcomes. Okay, and then these are the results for this indistinguishable analysis of fruit and vegetable consumption from the teen and the partner. Now, we're ignoring the fact that there's a teen and there's a partner, parent. We are ignoring that information. And so now what happens is really it's like we have one outcome and one predictor. We have an actor effect that's the same for both. We have partner effects that are the same for both. Notice that the residual variance for the outcome is fixed to be the same for both. We have R-squareds that are also the same for both. So this is the basic setup for doing this for indistinguishable dyads. Now, if you were working with indistinguishable dyads specifically, what you would have to do is put the data in with an arbitrary setting of who is partner and who is partner 1 and who is partner 2. So that becomes arbitrary. And these constraints allow us to then handle that arbitrariness. Okay, so what are some of the limitations of this, the analyses that we've shown so far? One pretty important one is that this is a cross-sectional design, and it's really not suitable for any kind of causal analysis of dyadic processes that you might be interested in uncovering. So we need to be able to address that. The other thing is that we also have, we don't really have a place for heterogeneity. So we have homogeneity. That is the case that the processes that we're looking at here are assumed to be the same for all the couples. And we want to be able to relax that. We want to be able to allow couples to have different processes. So in terms of next steps, we want to add a longitudinal context to this so that we can actually look at processes that unfold over time. We are going to actually use an intensive longitudinal design, a daily diary design in particular, to be able to allow us to estimate random effects, which allows for heterogeneity in terms of processes. And to give you an idea of what a longitudinal study is, it's one where we have enough repeated measurements to model a distinct change process for each individual and each couple. And that's it for my part. So now let me hand it over to Niall.
Thank you very much for the wonderful and informative presentation. Yes, are there any, before we move over to our next speaker, are there any clarification, burning questions that you wanted to ask to our first speaker? Again, we will have a long Q&A session after the both speakers, but after the both presentations, but anything that you wanted to clarify that you wanted to ask? Okay, so seeing that there is none, I would like to now introduce our second speaker of the day, Dr. Neil Bolger. He is a professor at the Department of Psychology at Columbia University, and he will give us his talk about, which is different now, I think, on intensive longitudinal design. Thank you very much. Please welcome Dr. Bolger.
Thank you very much. Okay, let's see what we have here. All right. So JP has, set this up in a way that I hope will make my job a little easier, but I'll let you be the judge of that. So let's just think about what he has just presented to us. We have a design. Now, here you'll see we have couples rather than parents and teens, but it's setting us up for the next example. But now imagine that our dyads are couples living together, and we could imagine a situation where we have distinguishable dyads, traditional heterosexual couples with males and females within each couple. And although he was presenting parent-teen dyads, it's really the same, it's the same structure that we can think about for any kind of distinguishable dyads. We essentially have a sample, and we can think about it in this sort of wide form where, there's the SEM approach, which, we have carefully avoided not mentioning multi-level modeling yet. And we will probably try not to mention it much at all because we are avoiding it to keep things straight. But for some of you, if you're approaching this from a multi-level modeling perspective, you might be thinking, well, what happened to all the levels of analysis and the random effects? Well, I mean, they're all there. They're just accounted for differently. And as somebody who really, I would say, is more of a multi-level modeler than a SEM person, I still find the SEM approach a little strange, but I can tell you there's many ways in which it is by far the easiest way to handle distinguishability. That's what we've kind of discovered now. And it all comes down to the fact that when the data are set up in this form where there's the two people that are distinguishable in the dyad, and you think of them as two different DVs, rather than in a multi-level modeling, you'd have them as two different levels of the same variable. And these things are really, they're very different frameworks. But amazingly enough, and if you look at our book on intensive longitudinal methods, we do everything through SEM and multi-level, and we get the same results. So the same model, as long as you know what you're doing. Here, we are focusing only on the SEM approach. And I hope by the end, you'll see why it is convenient for some of these questions. It also helps that we were asked to show this using M+. So, this did play into what we kind of know already. So just think about what JP talked about. So there, he had different dyads as well. And now instead of distinguishability being male-female, he had parent and teen. And this is sort of to represent the fact that what's missing here? Well, time is missing. The whole idea that people are changing, that these couples aren't static, that it's not just this cross-sectional picture. So what I want to add is a whole temporal dimension here. So you can imagine this structure here working for just, let's imagine now we have just, this is kind of represent diary days, or it could be any kind of intensive design. The thing is, you have to get out of the idea of just like one or two measurements. You can't use this method without having, and it's very hard to say how many, but 4, 5, that's the kind of thing that you need in order to make this work. I can certainly talk more about this, but what I want to give you the impression of is, imagine if we just had, like there's T, T, T. So imagine we have T1 for all of these couples. And I'll explain the data set in a moment. But that, if we just had one time point, then that would be kind of like what JP did. That's a one time point measure of the typical behavior of parents and teens. Well, in a traditional panel study, even if you were planning longitudinal, the first wave, like that first day, you could think of that as the first wave of a multi-wave study. Well, what JP did is a bit like, now I know it wasn't a diary, but it's just like that first snapshot. Now, what if you have all these additional snapshots now? What would you do with that? And what interesting questions? Well, it's a world of a difference because now we're talking about temporal processes. And with temporal processes like this, obviously you've got two people and they're sharing their lives together. And so at each time point, there's going to be things that are operating that make them more similar or more different. We'll get into this. But by adding in this temporal part, we can look at, of course, temporal processes, and we can also allow for individuality at the level of the dyad and even the individual within the dyad if you want. So heterogeneity, uniqueness of each couple is possible to study here as well. And then, of course, all of the important social variables that could matter for this heterogeneity, then they can all be brought in as well in this framework. Okay, so that's what I'm going to try and add. Now, in chapter, whatever it was, the dyads chapter of our book, it was the longest chapter. It's 40 pages long. It has lots of detail. But let's just, and this is you can call this a fake data set, but it's modeled on a lot of existing studies that were inspired by people like Rina Ripetti, who studied air traffic controllers at LAX and days on which they had a lot of planes landing versus not. And she did an amazing study that was a very short diary study of couples where this is way back, the husband was an air traffic controller. And, so she showed that it was possible to do these work stress studies and look at effects on the relationship. So this study is kind of like that, not air traffic controllers, but we have this, let's think of 100, so it's manufactured data, but this is a study that definitely, some version of it could be done. So imagine 100 dual income couples, we have 21 diary days, and then at the end of the work, so there's going to be 2 reports. Well, actually, normally we would get a report in the morning as well. First minute you wake up, get some sense of how you slept, how you feel. We would get that at the end of the day. But in this design, these people are, this is so pre-COVID, isn't it? I mean, it's like people go to the workplace. I don't know that happen. Does that happen anymore? I mean, it's starting to happen, yes. We're all starting to show up at work again. So imagine that we're back to a pre-COVID, you go off to work, you have a work day. Yeah, it's a bit old-fashioned, isn't it? But at the end of that work day, if you did have such a work day, you could say what it was like. You could assess it. You could say what events happened that were good or bad. And you could say how you feel about your work at the end of that day. So we're getting 2 reports. So the key analysis here is looking at events that happened in the workplace, predicting reports of the partners at the end of that day. So it is a within day kind of short term, a longitudinal in the sense that we're looking at work stressors and relationship variables the same day. Now, in a multi-level modeling way of doing this, you would put, everything is just all stacked on top of one another, and there's just, multi-level modeling has one DV, which is really hard to kind of keep straight with yourself because we have 2 different people, we have lots of different days. A multi-level modeling approach would just stack all of these data lines together and you'd have 4,200 data lines. And on each data line, you would have information on one of the partners on one of the days and so on. Now that is not the SEM way of doing this. So the SEM way of doing this is to have 2100 data lines, because what you do in SEM is you separate out the two partners into separate DVs. And that is what JP's been showing you, and it's what we're going to do here with these data. So what does that look like? Did I switch this off somehow? Okay. Okay, so these are just some information about the data, and we're going to show you some numbers to try and make it give you a sense of what this is like. But roughly each member, and this is traditional heterosexual dyads. But this, when we get to non-distinguishable dyads, we'll have a much more general way of doing this. But we're going to start off this way, and both male and female partners have around 3 stressors a day. And on a 0 to 10 scale of their relationship satisfaction, dissatisfaction, they're around a 5, although the females are a little bit lower than the males. So we're going to ask these questions about work to home stress carryover. And, well, we're going to, let's just keep going here. We're going to just explore what you can show with an actor-partner model and longitudinal data with this sort of data set. Well, who says you can't put 100 couples up on a slide in one go? So there's male and female partners here, and you can see in couple number 2, now the males are in the light colors, very hard to tell here. But there's a male who's a lot more dissatisfied than the female. Do we have this coded that way? It's higher scores and more dissatisfaction. Yeah. So you can see, but there's a lot of change, but there's no change that's going anywhere in particular. They're going up and down, but they're not changing in any sort of direction. So it's staying pretty level over the 21 days, but some days there are more, there's more relationship dissatisfaction than others. So this is the DV, and both partners are being shown on the same slide. So I don't know whether, I've firmly believed that we should always be looking at these things before we do anything fancier. I mean, and it's not that hard to do. And, it is amazing how much you can see all together. Well, that gives you a bird's eye view of the temporal structure of the data for each and every person. In fact, for each and every data point. I mean, every data point on that DV is visible to you there. And I like trying to do this before getting fancier. Here is the work stressors one, and it's more choppy, but it, and this is, I wonder, is it possible to make this more in focus? But maybe it isn't. It's sort of out of focus at the bottom here. But anyway, you can see that, there's probably less differences between them in their work stress on average. But some days are worse than others. And that is actually the key to this design. You really do need people to change for you to be able to see these within couple processes. All right, so we've shown you the X, and here's every single score on X, the predictor for each and every partner. And now, so don't be fooled here. This looks just like JP's actor-partner model. And it is an actor-partner model, but it's based entirely on within dyad variation. So you have to think of this as being a kind of, how shall I put it? So remember I mentioned that like if we had just looked at the first day and we'd done an actor-partner model. And so we can think of this as, so let me just remind you that this is work stressors of the male partner, relationship dissatisfaction of the male partner, work stressors of the female partner, relationship satisfaction of the female partner. That's the question. And We could have asked it in a between couples way by just taking the very first day of the 21 days. And we could have estimated a model like this. It would be a cross-sectional model. And I'm not saying it would be the absolute worst thing to do, but it would be cross-sectional. But still, this would be, on the first day, how much you had work stressors that day, if you were the male. And then this would be how dissatisfied you were at the end of that day. So if we had analyzed the data that way, that would be a between couples analysis. So I hope I'm being clear. So what it would be is that you'd be saying male partners on that first day who had more work stressors had more distress than other male partners. And the same would be true down here. Those female partners that were higher on work stress, are they higher on work dissatisfaction? But it's all at the same day. What is this now? Well, this is using a we've essentially separated the data into two pieces, a between piece and a within piece. So the between piece we're not going to be looking at, but it is like analogous. Let me just go back to this here. So you could imagine that if we just took each separate time point, we could imagine a kind of APIM that's cross-sectional for each and every time point. So imagine all these cross-sectional APIMs. Now, they're all on the same people, but you can imagine doing this. And what I want you to realize is that were we to just somehow average over all of those and sort of talk about, well, what's the general picture at a between subjects level, that would be the between subjects part of the data. That's what that would be. But we don't want to look at that. Now, you might say, why don't you? But we want to see what we might find if we say, take that male and we compare him to himself, the previous. So on days on which his work stress is worse than it usually is his relationship satisfaction worse than it usually is? So that's a different research question. So instead of saying, if some males are more stressed at work than other males, what are they like on their relationship satisfaction? That's a fine question. It's very important. But what about on days on which you are more stressed than you usually are? Are you more distressed? Are you more unhappy in your relationship? So I want you to understand how different that is. And what's interesting is that they are two orthogonal pieces of the variance that you get when you do these kind of diary studies. So what have we got here? We have a within couples, within person, within couple over time model now. And what this is some, well, it has lots of things that are similar. You've got the two X's, the two Y's, you've got the actor effect, you've got the partner effect. And you've got this correlation and that correlation. And of course, you've got these intercepts here. So not only is the question different, but now these things, so notice these things now are black balloons, circles. That's meant to indicate that they are random variables that have different values for each and every male partner. And each and every female partner has their own, if you might, what we might call reactivity to work stressors, or tendency for the work stress to go home, to affect what they report at the end of the day from what happened during the workday. So this A sub m, well, this is the beauty of latent variable modeling. Now we have a whole new variable that indexes this interesting heterogeneity in the temporal process. So all of these can, and I mean, we'll show you now in a second what it looks like, but these things, so now we have all these new variables that we didn't have before, and they are definitely require some getting used to think about what they mean. But I think they, you know, especially if you visualize them, you will get a lot out of this sort of analysis. So let's just go further into it here. Oh yeah, well now this, okay, let me just see what I've got here. Okay, well you have to go through this to get from here to here. Yes, so that's, and right, so what have we got here? Well, this is all available. I guess this is, all of this material we can make available to anybody who wants to. I mean, we have these files. This data set is freely available just online. It's on the book website. You can get this data set. This code is a little different from what we've used in our book, but it is fundamentally what we do in the book. So we're still sticking with. Once again, the big difference between this and multi-level modeling is that, well, it's that we have two different DVs again. So it's just that is a, sorry, I think I hit my mic here. So this is a, again, using this wide form with two DVs and over time. All right, so there's a lot of, you know, it isn't helpful to take you through this in detail, but this is just standard M+ code for representing random effects. So here's the female's relationship dissatisfaction regressed on her work stress. Here's his relationship dissatisfaction regressed on his work stress. They've all been made to be within person, within couple. So we've already removed all the between person and between couple variation. And that's like a huge thing to do. But the benefit is that now you're looking at, now the comparisons are within person, so within unit. So we're talking about people here, but you know, it could be any paired unit. We want to be able to look at change over time, and that's what's being picked up here. And M+ has really kind of swallowed up multi-level modeling, not entirely, because I do think there's things that are not easily seen in the SEM approach. But the bottom line is that you can get results like this. Now these are the same as we showed in the book. So this actor effect, it's smaller than, you know, you were seeing. We're still talking about 0 to 10 scale, 0 to 10 scale. So this says that on days on which the male partner, for every one additional work stressor that male partner reports that day, they're 1/10 of a scale point higher for each additional work stressor in distress. Now, given that there were 3 work stressors on average, you could probably multiply that by 3. So on a typical day, that, you know, if that's per 1 work stressor, so if you have 3 on a day, you know, your distress will be 3 times that, because that's a per work stressor's coefficient. But it's inside this balloon, which means that that's an average. So that's just the mean of what is modeled as a normal distribution. So everybody's allowed to differ in this effect. And that's the average male partner's effect. somewhat bigger for the female partner. And again, this is per work stressor. So there is there's slightly more, if you call it reactive. This all depends on, how you measure work stress. But if we just leave that aside and just take these for what they look like on the face of it, we have these actor effects and no partner effects in these data. Don't take that to mean there are none. We didn't simulate them, so obviously. But I would guess for sure with real data that you would. But but this is you can think of this as on the road to non-distinguishability. And again, we can do it here because we can constrain these to be the same. And in all the ways that JP was talking about, we can convert this into an indistinguishable dyads analysis in the same way. And that, well, hold on. Let's just absorb this a little bit more before we talk about non-distinguishable. So this looks so simple, but these are now random effects. So how do we visualize that? Well, one way is this way. So each of these lines this is a spaghetti plot, of course, and here are the female partners, here are the male partners. Here's the average slope for the female partners, the average slope for the male partners. What you can see here is a lot of differences a lot of intercept differences, not relative to slope differences. We're only plotting the data where the data are for particular people. So this person didn't have any. Nobody had. Yeah, I guess somebody had no stressors because this goes back further. But what this is trying to show you is there's a lot of similarity, but there's also differences. And that is what is picked up by this and this. So we're now looking at these things. So this would be around a 0.16 per unit. Now, can you do the calculation? It's like, but that's what it looks like on average. So we just keep adding a constant amount for each additional work stressor. Slope is a bit lower for male partners. So if you do an analysis like this, I think you'd be selling yourself short not to do a plot like this if you can. And that's also something we recommend for this sort of model. This won't be easy to get from SEM. So SEM is not good at predictions and plots and all the rest. But I can assure you, you can do this model and you can get the same results using both methods. By methods, I mean multi-level modeling and SEM. So the fact that it's harder to get this out from SEM, but you can do it. Like we have done this. We've gotten out predictions, right? And we've been able to do these graphs. But I don't want to make it seem like this is easy. This is actually a slightly harder thing to do in SEM. Now, this is the thing I really wanted you to see. So what we can't see here is that this random variable can correlate with this random variable and with this one and this one and this one and this one. There's a whole covariance matrix of all these of this heterogeneity. And this heterogeneity, you can think of it two ways. One is you can just document what its size is. And I think that's like I think it's a mistake that people make to just jump straight to explaining heterogeneity. That's as Professor Umberson knows, this is an important descriptive fact about any population, the heterogeneity of effects. So it's a population idea, I think. I mean, I think it really is. And so we know populations are heterogeneous. And here's a model, and here's, I'm not sure why this is, let me switch it on again. And here's one way of showing it. Now this way, let me just take my time here. So this is showing you what some of these covariances between these random effects look like. And I think they are quite interesting. Here is, well, so these are the intercepts. So these would be like the average levels of distress across all the diary days. And there are different, you can see that those males that are more distressed on average, so this is the between part, if you like, a kind of between, they're paired with female partners that are more distressed on average. And you know, there's a particular couple there that both are high, both are low. He's high, she's low, she's high, he's low. You know, and this oval represents a correlation of 0.26, and these are the dots. So each dot here is a couple, and we can just see them around, you know, and that's, you know, that you can't see that here, but that's part of the covariance of these things. All right, but this is the part I really want you to look at, because this is the covariance. So sorry, I didn't make it clear, but that covariance we were looking at was the covariance between, sorry, you could call it the intercepts, the average levels of M and F. But I want to show you what is the relationship between the slopes for the male partners, for which the average here is 11, the average here is 16. Okay. Well, now the average here should be around 11, and the average here should be around 16. And this is showing you a greater linkage within the dyad of their reactivity to work stressors, the spillover part. And again, we can find some couples that are very high in this slope together and very low. It's harder to find the off diagonals, and this is the correlation. These are the predictions for the sample. This thing is where we are supposed to believe the population is. And that's another thing you should try to visualize. In order to visualize, you have to get out these things, but those predictions about so here's a couple where his slope appears to be around 0, but hers is really quite high, or it's positive, much more positive than his is. His is about 0. So we can see that there's a general tendency to go together, but not perfect. And again, more that you need to show, for which this is the typical couple, right? So this is what this is. This is the typical with, you know, daily process for the typical couple. And then this is an attempt to show heterogeneity of various kinds. Okay, so let's see. All right. So for most of our careers, JP and I were thinking back, you know, we've been doing this a while. And we have mostly stuck with distinguishable dyads. And that's a pity, because there's so much more out there now. And so it's really time that we figured out how to do this. And I'm happy to say, I think we know now how to do it in SEM. And the reason it's tractable in SEM is for the same reason that it worked for the cross-sectional case. If you have distinguishable dyads, you lay out the data in this form that JP was showing you. If you have non-distinguishable dyads, how do you handle them? Well, you've just got to arbitrarily give a code to one of them and another code to another. It's just arbitrary, like just two codes, like P1, P2. Doesn't matter which you give. You just They just have to be different. We can talk about this afternoon. I know you were interested in this sort of idea. But if you do that, if you give them separate codes and you set up an SEM like this, well, if they're non-distinguishable, then making them distinguishable just arbitrarily is just the step that enables you to get this structure and then constrain it and get a non-distinguishable result. Sorry, I'm hoping that I can be more clear about this, but I want to just show you. Now I guess we are finally looking at the multi-level idea here, which I think is hidden by SEM, but it's not that SEM doesn't take care of it. But really what we have are 3 levels of analysis. I mean, I think I was confused by this for a long time because JP and I, following a famous paper by Raudenbusch back in the 90s, who showed us like an example of how to do this with distinguishable dyads. What happens when they're non-distinguishable? So we have to imagine now a situation where we have a couple or some kind of dyad, and now these are just 2 people. They can be any, it doesn't matter. We don't know. I mean, when they're non-distinguishable, they really are non-distinguishable. Like they're just arbitrarily different. You might think that's a bad thing, but that we don't know. But there are, I think there's advantages, and let's just consider those. But be aware that there is a middle level here, and this is random. If I don't know the identity, so okay, there's only 2 people, but I can imagine sampling from those 2 people, and I won't know who I'm going to get. So that tells you immediately it's a random variable. I don't know who I'm going to get because I can't identify them. It's like they're just two balls, and I just, if I pluck out one, well, it could, whoever that is, I can't distinguish them. So how do I do this in SEM? Well, you first of all, so this is the kind of annoying part. You have to if you have non-distinguishable dyads, the first step is to make them distinguishable on just for any way you want. And then constrain. So now we have, okay, the thing to realize, JP pointed this out. So this is apparently still a wide SEM, but it's misleading because there really isn't 2 X's and 2 Y's anymore. There's just 1 X and 1 Y. So you have to imagine collapsing here. And now we have just 1 A and 1 P. And that's all you're going to get with non-distinguishable dyads. But remember, that A, and it's the same A as here, it's a bit confusing, but there are going to be some, what can I say? They're going to be, those random effects will be at the couple level, isn't that right? So some couples will have bigger partner effects, and some couples will have smaller partner effects. Bigger actor. So we'll have couple differences here, and we can look at those same correlations, except there now will just be 1 actor, or one actor coefficient and 1 partner coefficient per dyad. Okay. So, my God, there's so much less code here. Why is there so much less code?
Continues on the next
Okay, it's even more code than last time. Okay, I was thinking, this is a big improvement on the last time. Okay, well, there's even more code here. So clearly, you can't just do this, rustle this up in a morning, but there's no shame in copying. I firmly believe. Copy, copy, copy. Give credit, of course, but so yeah, it's a mess to look at, but we have started to put these constraints in again, and I forget where they are. Like this is we're constraining the intercept variance, we're constraining the x variance, we're constraining the intercepts, we're constraining the x's, and this is a covariance. And here is the bottom line for this analysis, which is that instead of having a 0.11, was it, and a 0.16, we now split the difference and get 0.13 as the actor effect and 0.01 and 0.01 for the partner effect. So this is non-distinguishable dyads, and it also is longitudinal, and it's within couple. And obviously, some of these things won't be the same when you don't have distinguishability, but you will still. There's still a lot of things you can display, and we just haven't. We haven't played with this yet. But I want to draw your attention to this thing here. So we have two partners. And in SEM, as JP said, when you can distinguish them, that SEM model is saturated. It's just classic saturated model. Now this model is absolutely not saturated. There's a ton of constraints in here. Everything that can be constrained can be constrained. And so you see, this A, so you have to imagine, so we already know these are distinguishable, and we're treating them as non-distinguishable. Now I think for this to be useful to you, you have to also imagine, what if you started with friendship dyads or gay and lesbian couples? You will then not. You'll still, if you use this approach, you just again, as I said, give them some arbitrary code and constrain, and you get this pattern. But hidden behind here, so here's the difficult part, at least for me. We have an actor effect, but it has, in a multi-level model, this variance would be called person within dyad. So and if any of you have used any of Debbie Kashi or Ackerman is another course you had recently, they have examples from particularly SAS on how to handle this in a multi-level modeling context. But these are two different people, obviously, and we could imagine them having different actor effects, but we can't identify them. We really can't, but this constraint here is, by going from a saturated model to a non-saturated model here, is like going from a two-level model, when you can distinguish the partners, this three-level model collapses. I don't think I have collapses to, oh my God, look how far back it is. It collapses to a two-level model. This is a technical issue, but unfortunately it's important. So when I learned how to do this, and JP learned how to do this, we had as our example distinguishable dyads, and we had a multi-level modeling approach to dealing with it. And it turned out that that approach was not a three-level model, because once you know who's who in here, whether that's a parent and a teen, or a male and a female, or any kind of distinction, a therapist and a patient, a mother and a child, all of these things. Once they're distinguished, this collapses to what's called a two-level, multi-level model. The difficulty, and the reason why it's taken so long, I think, for us to tackle indistinguishable dyads is because that opens up a random effect in this middle part here. People can differ within dyads. So I hope you can sort of understand that when I know that this is a dyad, and this is the parent, and this is the child, then there's no uncertainty at this level of the individual within the couple, because it's essentially you've gone for broke with gender. Gender's the one. You've chosen it, and that's gotten rid of this middle level of randomness. This middle level of randomness is back now. It's just you can't see it. So this thing here is an average. Now, when I say that you can't see it, everything is taken care of here. Like there's nothing, like this is statistically, there's nothing wrong with this statistically. It's just that I think if you were a multi-level modeler, you'd realize that you're now using a three-level model. If you're an SEMer, well, I don't know that you would. I mean, what would you call this, JP? It's two-level, yeah. So I'm just telling you what we sort of have discovered here, but the good news is that if you are an SEM user, you can, I think you can, this seems like a kind of an easier way to go from distinguishable to non-distinguishable than the multi-level way. But I'm sure people could disagree, and maybe there are good examples. But as a multi-level modeler, I can just see the advantage of going this route. And I'm very eager to get your questions about this. I mean, what does it mean and all the rest? But this is perfectly general. Like this also would work for triads, tetrads. This is a general approach. It's just that, if you had a triad, you would have a third thing here and a fourth thing here, and actor and partner effects. So, but I'm speaking as a I don't think often in terms of SEM, and it still bothers me that somehow this is kind of handled. And I mean, it is handled. It's just kind of like hidden. And I think JP and I have been discussing that it's something to do, what in a multi-level model would be a separate error term called person within couple becomes a kind of deviation from saturation in SEM. Does that make sense? I mean, anyway, this is what we've discovered from kind of working on this. I mean, I think it's great that you invited us here, because it finally made us kind of knuckle down and figure some of this out. So you can do a longitudinal dyadic process model for indistinguishable dyads, looking at work stress and spillover into the home, allowing for individuality at the dyad level. Now, there is something there. If it was a multi-level model, we would be asking about this variability, and that's what's kind of hidden, I think. So So I want to, let me see, I think we're just about at the end, because this is really something we need to talk more about, I think, to sort of explore more. But this is our best guess as to how to handle this in SEM. But here's what I think you can't do easily is, now that we're in non-distinguishable dyad territory, that person within dyad difference is, well, I think it's very interesting. I know it sounds very technical, but imagine you go from a place where we're always studying these distinguishable dyads, and we forget that these are actually individuals that have all kinds of different backgrounds and needs, everything, all the things that we know about real dyads. Well, that's somehow is left in this model in an interesting way. And, so what am I trying to say? I think I'm trying to say that there's a thing that would be kind of like a standard deviation that would describe the within couple differences that you can't get with distinguishable dyads. And so the kind of thing that is essentially, if you've gone for gender, then boom, gender takes up that variation. But anything would do the same thing. Any person level variable would do the same thing. So what's the benefit of not distinguishing people? Well, I think the benefit is that suddenly you start to see the variation within couples that we were sort of ignoring, or we were always attributing it to gender. So if you have distinguishable dyads, well, it's silly to think that you should pretend they're not distinguishable, but clearly it's not a big deal to switch. If you're in an SEM framework, it's not a big deal to switch. You just put constraints in there and you get a distinguishable model, non-distinguishable model. And so I look forward to, and I know that in the HARP study and your longitudinal study, so you've got all these different kinds of dyads, some distinguishable, some not distinguishable. Well, clearly there's a way in which we can treat them all as non-distinguishable, but keep the differences between the groups. So that's one way to go. The other, and we think it's possible in M+, is that you would have multiple groups. And in those multiple groups, in one group, you'd do a distinguishable analysis. This is very much an SEM thing. I mean, I don't quite know how you would. I'm not saying you couldn't do it in multi-level, but it's certainly not easy. But in SEM now, you can imagine a multi-group SEM where some couples are specified like this, but other couples, well, are specified where they're allowed to be different. Now you can do that. Now what do you do after you've done it is another question, because now how do you compare them? Because now they're not comparable in interesting ways, but I think that's what's going to make it interesting as we move forward. But I've been warming to non-distinguishable dyads, I must say. And it's good to know how to actually do it, or at least we feel some sense of, well, JP's not as sure as, I mean, I think this will work. I think you can do it this way, and I think you can do a multi-group analysis where you have all of these together. I haven't had the pleasure of trying to do that, but we can certainly talk to you this afternoon about how you would do it. I mean, I don't think we see any problem in principle. Right? So I'm sure you've got a ton of questions, but I hope that this gives you something to chew on. Thank you.
Thank you so much for the informative and wonderful presentation. Now I would like to first open the floor to those over here for any questions that you want to ask to our amazing speakers about their presentations or the future of all these woods of analysis that we need to pursue and go forward with.
Mm-hmm.
Yes.
I only have like 8.
For the audience online.
All right, so
Do we sit? Should we sit up here?
Yeah, yes.
Okay.
Yes, so that you can
Okay.
face the audience.
So I know you both said this many times, but I'm just going to check my understanding anyway. When you say that we could just do this with arbitrarily putting a partner one place or another, you're saying you don't need to randomize it, anything, just whatever you want to do. And no matter how you do it, you're going to get the same outcome.
Yep. That's right.
If you place constraints.
If you place constraints. Okay. And I guess, so another question I have, I just wanted to make sure that was, because that is not how I've thought of it in the past. But then another question I had is when, I did have another question. Well, okay, I'll go to my
I think you said you had about 8
I
questions.
do have 8 questions, so I'm going to go to one of my other ones and come
Yeah.
back to that
Well, you
one.
can go down to like number 6, for example.
So in SEM, so I, as you know, am a multi-level modeler, not an SEMer. Are you centering your variables? Would you within couple center in the indistinguishable?
Yes. I mean, you can. We're not doing that explicitly in the SEM approach, but if you were doing multi-level modeling, yeah, you would have to have something that had a person within couple, like you'd have a couple level, and you'd have a person within couple level of analysis. So that you would need for SEM, but it's kind of hidden, for multi-level, but it's kind of hidden in SEM, isn't it? Because really that within is now in this wide form, right? Because we've got the 2 people, and if they're distinguishable, then you've got 2 completely different DVs. If they're not distinguishable, you arbitrarily create differences and then constrain them so that you end up, again, getting some average. So it is correct to say that A that we get is a kind of an average within couple. It's an average for that couple. But we didn't calculate it as an average. It just popped out as an average because we just said, okay, there's 2 different people here, but we're going to ignore that they're different, and we're just going to split the difference. And you notice that's what happened with the coefficients. Like if you had 11 and 16 and you ended up with whatever, 14, 13, the middle of the. So, but back to your language of multi-level modeling, if we were thinking of this as a multi-level model, we would have to separate between and within at the person and between and within at the couple level. So there's 2 different. So you see, in that sense, you are kind of bringing 3 levels in because you've got the time, person, then person, dyad. So in multi-level modeling, you have to chop those things up yourself by creating variables, and some of that that's in our book, all over the place in the book. Because one thing that in multi-level modeling you have to do is you have to separate between and within subject variance on X. And the model doesn't do that for you. And so you have to do it. So one of the first things that people who do daily diary work discover is that you have to create two versions of X, the between person version and a within person version. So by analogy now, if you want to think of now the couple level, so now you might have a between couple level, a between person within couple level. So now I'm speaking like a multi-level modeler now, and then a within person level. So, and they could all be handled by, in multi-level modeling, I think what you would do is you just have to create those means and subtract them. And so it's, you can see it's, we thought about how we would present this, and it seemed so messy to do it, to try and explain it in a multi-level modeling framework that we thought it was great that you asked us to use M+, because, but I do think there's something that's lost about levels of analysis. And anybody in this room who's got any sociological imagination should not forget that there are levels of analysis. And we shouldn't be thinking it's all at the person level, or it's all at the, I mean, obviously there are higher level social structures too. But this is a framework that, you know, what I've always liked about multi-level modeling is that I feel like it finally enables us to sort of start to tackle the levels of analysis problem, which is a classic one in social science. And I feel like we're doing it here too. I mean, even though we're not really going, you know, obviously it's a very low level structure, the dyad and the individual, but it actually does generalize, you know, if you've got work groups or if you have counties, or, you know, so there's a lot. I could imagine, especially with your population orientation, a lot of very interesting analyses that you can do. Key is heterogeneity is front and center here, even though I think it's a little hidden. But, you know, hopefully those graphs you could see that behind all these like numbers and circles, and, you know, there are actual predicted patterns for individuals. And that's what I've always liked, and that's what I've always liked trying to do. And so in our book, it's full of pictures. Right.
Because I always describe it as a picture book.
It's more pictures.
Talking to others.
And I make no apology for that, because I hate just numbers all the time. Don't you just hate just looking at a number? You know, like, how about a table of correlations? Notice we didn't force that. We just showed you like M+ code, which is much worse. Yeah.
So in this model, would you be able to add a individual predictor and get like like if I were looking at neuroticism as a predictor of stress spillover? Neuroticism is measured at the person level. Mm-hmm. My people are indistinguishable. So would it model each individual in the couple, but then take their average?
Yes.
I mean, essentially, I'm sure it's not exactly
all right.
average.
So, well, you asked, do you want to?
No, go ahead.
Yeah, I mean, you're going to have to create versions of X that are a bit strange looking. But I think this is what, like, if you want to do this a multi-level modeling way, so one way you could do it is to calculate a couple average and a person deviation from that. And so one analysis you can do is you can have 4 different, JP will correct me if I'm getting some of these wrong, but these can all be in the same multi-level model. One would be, so imagine the X, so if the X is work stressors, we could have that there is the work stressor of the couple as an average. So across all days, you have a couple average. Now within that couple average, there will be 2 person averages, but only one is identifiable, because once we know one, we know the other. So there's a person within couple variability but it's all still between. So I've separated the within now from this. But imagine these different versions of X. Between couple X, between person within couple X, then you have a choice, but you could do couple over time, and then person within couple over time. That's 4 different versions of X. We can talk about how you'd calculate them. They all can be, they're all orthogonal, believe it or not. They are all uncorrelated, and they can all be predictors in a multi-level model. So now you have, some of these effects I'm not personally that interested in, but you could ask, are those couples who have more work stress on average, are they the couples that are more show more dissatisfaction in the relationship on average at the end of the day? So that's a between couples level, and it's all averaged up to the level of the couple. So that's a couple level effect. Now, back to your neuroticism question. So there's still this person within couple variability. So how would you handle this? Well, if you put neuroticism as a predictor, you've now saturated that model again. Isn't that right? I mean, you can only, because you can, because it's, so, I mean, this is thanks for that tricky question, but neuroticism, well, you could create a couple level of neuroticism, couldn't you?
You could, yep.
Yeah, so even though it's a strange idea, no, it's not that strange. Highly neurotic people just pair up and marry, and then they have even more neurotic kids.
I hear they're the happiest couples.
Yeah, all right. So you can think of neuroticism at the couple level. Then you can look at differences between partners in their neuroticism levels. But that's all you can do, because there's no temporal variation. So I think I'm hearing myself, I'm just hearing myself say this, which is that I think you can create a couple neuroticism and a person deviation for neuroticism, and that's how I would handle that. So neurotic couples, and then if I'm especially neurotic compared to my partner, does that matter? Probably. So there are 2 very different types of effects, and they're there to be estimated. I think that's right. Does that make sense?
Yeah.
Yeah. Neurotic couples. It's the couple average.
Well, thank you.
Have you tried? I mean, should try it.
Being in a neurotic couple.
I wouldn't. No, I'm not speaking personally, of course.
Yeah, no, it's really interesting. Actually, the deviation, I think, would be an interesting way to look at it, rather than the 2 people's levels.
Right. So that deviation, I struggle with that. What that means. So one interpretation of that couple, that person within couple, is that it's a person level effect. But because we're controlling for the couple normally, it really is a kind of contrast within the dyad. If you've just got 2 people. If you've got 3 people, then it's just some kind of difference between, average difference in the couples. But I'm harping on that person within dyad because you can't see it in our analyses. And I do think, whereas in multi-level, so just to make sure we're all on the same page here, it's really been it's a big move in multi-level modeling to go from a 2-level to a 3-level model. Whereas it's kind of more like a piece of cake. But maybe it should be harder. Maybe it's too easy. Now I'm beginning to worry about our approach. It's too easy. Because you have to work for your results. And sometimes, but I hear, we would be giving you a much more, I mean, if you found this hard to follow, I assure you it would be much harder to follow had we tried to show you the multi-level way of doing this. And I think that's what, as we were preparing, that's what conclusion we came to. But I will say, because we have always found this, they're the same model. At somehow, like it isn't, the integration of SEM and multi-level is still a work in progress. M+ is the best that we have. Stata has some good, I know you can definitely do all this in Stata too. And they have SEM, I just don't know how good, but they've certainly incorporated SEM. But I mean, as I see my education as a methodologist, it's been trying to find a way to manage both of these kind of models together. And they are, in the end, I mean, we're all going to be doing some version of multi-level SEM. That's what I think we're all headed towards. Or at least it's a very flexible, because you have all the tradition, and it's very strong in sociology of SEM, and now you've got the multi-level work from demography and education and other fields, and the marriage of those two is what I think what we need. And for now, although I think R will eventually overtake it, but right now I don't see anything better than M+ for this. But what JP and I always do, and we haven't done it yet with this, but we will, is we always do it both ways.
Got to reproduce.
Yeah, we always, and we have always succeeded to get them to agree. So that's the good news, but we haven't done it in this particular case. But we're trying to think about what, given you have amazing data here, and it's only going to grow, right? So you're going to have heterogeneous types of couples, and you've got the temporal and you've got different waves. I mean, I think the kind of work you're doing here is perfect for this integration of SEM and multi-level. But it's still a work in progress. I mean, I don't know anybody. I'll tell you one thing that we discovered as we were preparing is that there is now a 3-level model that you can use in M+, right? Well, we've played with it. It's not ready for prime time. Like it isn't. There's a lot of things it isn't good at yet, and so we were able to. I think we're oversharing here, but we did figure out how to do 3-level models in M+, and we abandoned it for reasons that were
for the outcome.
Yeah,
the outcome. It worked.
Yeah, but not for the X to Y. So we're showing you something we can stand behind. But look, it's all. I mean, the good news is that we know so much more. Like when JP and I were in graduate school. Well, JP is a younger man than me. But let's say when Deb and I were in graduate school, we knew nothing, right? I mean, it's incredible how little, or Karen, I mean, you're not going back that far, right? But part of the way, like, isn't it amazing how much better things are now? Well, I think they are anyway. I mean, I think I know a lot more about how to tackle these things than I did 40 years ago. But you can see it's there's plenty more to be done. And it's so exciting. I really think the data you're collecting here it's historic, and you're going to be able to use these models. You'll give them a good workout, I think.
Well, thank you. I will save my other 4 questions for
Okay.
another time.
All
Let
right.
somebody else
And
ask a
I need
question.
to let JP do a little bit of talking too.
Yeah, we have questions.
Okay, at the back, or no?
I mean,
You can start from the back and then come back, I guess.
well, thank you for the great presentation. I really enjoyed it. I'm sort of following up on Marcy's question, but I love the idea of treating in this distinguishable data dyads as a 3-level rather than a 2-level cross data.
Yeah.
So that's, I think, really interesting. But wouldn't there be a benefit to treating this data as 3-level as opposed to the 2-level data that you treated as in the M+ setting? I ask that only because I think there's a way to, rather than doing the multi-group analyses,
Yes.
for example,
Yeah.
I think you can treat, so if you retain the 2nd level,
Yeah.
then you can include different types of dyads, such as heterosexual couples, same-sex, so gay couples, lesbian couples. All that can be a level 2 predictor, which I think could be very interesting.
Yeah.
And then you can include individual gender/sex as the 3rd level variable. And I think you can do a lot of interesting things that way. In the multi-level framework, I think that's, I also use multi-level models primarily, so that makes more sense intuitively in the multi-level setting rather than in the SCM setting. But I was wondering if you had any thoughts on that.
You're a multi-leveler. See, that's the issue. I'm not a multi-leveler.
Yeah, but we make a great couple, though, right?
That's right. That's
Yeah.
yeah. Well, we do multi-level SCM.
We do. That's
the idea.
That's the couple level effect we have. So wonderful. Well, we played around with. Well, the difficulty for the 3 levels, that middle level has only 1 degree of freedom. Once you know, one person in the dyad and you know the dyad, there's only 1 more piece of information. So I think I know what you have in mind, but if you really think of individual variation within the dyad, it's 1 degree of freedom of information. And it can have, you can interact it with time, and so you can have person by time within dyad, but I don't, you see, I'm having trouble seeing how you can bring in a person level predictor at a person level when there's only 1 degree of freedom there. So you've got to do something with those variables. See, this is the problem. We have traditionally used gender as the organizing variable here, and it makes, I can understand why, but when you then you say, well, of course they differ by personality, they differ by their income, by their socioeconomic background, by their, by their orientations of various kinds. There's endless ways people differ. But if you are taking a hierarchical approach, you can't get past that there's only 2 people. So I think whatever you're doing, maybe we should talk about how you're setting up the analyses. But that I think is the fundamental problem with there being 3 levels. That middle level is very well, there's just 2 people, right? So if I know the gender, that's all I need. That's it. There's no more randomness. So that's That's the problem I would have with the idea that you could put in a whole load of individual predictors. Yes, you could, but not with this design that I can, I mean, what?
Yeah, I mean, I agree. with that
Or if
middle
there's a
level.
sense in which you can do it, it can't be using that middle level of the data. So I think we are, I was saying to JP yesterday that, if we get talking about levels of analysis here, we can get ourselves into knots. But that's what so how would you do the analysis where you could properly take account of the dyad level? Now, if I just say, to hell with dyads, I mean, these are just people. I'm now going to have a whole bunch of people, and now I can definitely do all that. I can use all the individual predictors. But what if you are concerned that those predictors have couple level variability, and I can't let that, I need to give that to the couple, right? I need to respect levels of analysis. So if we take a variable like neuroticism, that's an individual characteristic. But who's to say that it doesn't have an existence at the couple level because of selection or various processes by which couples come together? Well, anyway, that's my difficulty with that individual level. But it becomes problematic because I'm saying that there is a couple level and I don't want to ignore it, and I want to model it first. Now I can tell. I mean, we're not connecting. But I think I'll bet there's a way in which you can do what you're doing. But I think you are. You can't be working with that little piece of variance at the middle. That's all I'm saying. But I'd love to know what you are.
I don't have anything to add to that. I was just curious as to know. I mean, the 2 degrees of freedom is an interesting thing. I wasn't really thinking with that in mind, but now that you give that explanation, I will have to also think about that more.
Well, there's a ton of individual variability.
Right.
In a sample of dyads. I mean, look at all those people. Like, there's 200 people so there's tons of, it's just, what is that? If it's something that exists very clearly at the dyadic level, don't we want to recognize that and create dyad level, and in multi-level modeling, you'd have to create dyad level scores. And now we can get into an argument about levels of analysis. Is that really a thing? But I could believe it. I could believe that, people come together, they connect on pre-existing, just think about social attitudes these days and how the country is divided, and those things are individual. But when you've got 2 people who really agree on these things, then it has a life as a couple level variable, I think. Well, certainly you can calculate it. You can, and somebody might say, well, what is that? Well, that's telling us the neuroticism level of the dyad. And then, so then the person within dyad is saying something like, well, yeah, they're both pretty up there on neuroticism, but he's way worse than she is, if that's possible. I mean, I'm just thinking of things you say. Yeah, they're bad, but he's But so you can imagine that the couple level is high, but there's still some difference. But you see, now what you've done is you've attributed to the couple what we'd normally be attributing to individuals. And I like that idea. Because if it exists at the couple level, then why not think about it that way? So people do this, with attitudes as well. What's the attitude of a whole state? Well, you can average. And then is that a causal variable? Well, I leave that to those of you to think about. But but we've kind of not really shown you that side to the data. But I can tell you, 2 40-minute talks wouldn't be enough to cover it had we done that. Okay, I know you had a question.
There's another question.
Hi, thank you. 2 quick questions. The first one I think is pretty straightforward. Are equidistant data points required for this sort of analysis?
Not necessarily, because M+ can handle unequal intervals now.
Oh, okay.
If that's what you're asking about, like an ESM design or something like that, where you have multiple times throughout the day, but they're not all
Right.
spaced in the same amount. Yeah, there's something called T-interval that allows you to handle that in M+.
Okay, thank you. The second quick question. In an SEM framework, to identify partner and actor effects, is that done simply with a distinguishable model, or is it testing path differences from distinguishable and non-distinguishable models?
Can you repeat that again?
So
I understand that.
in a non-distinguishable model, where the effects are constrained, would that be, in essence, a first step to determine if there's an overall association, and then a next step would be to distinguish those dyads and test for the separate, freely estimated paths?
I think it depends on whether you're starting with distinguishable dyads or non-indistinguishable dyads. If you're starting with distinguishable dyads, I would say start with allowing them to be different so you can see if they're different, and then you can constrain if it looks like constraining makes sense. With indistinguishable, you don't even have that option. All you can do is estimate one actor effect and one partner effect. So.
Great, thank you.
Thank you both for your talk. It was great. This kind of goes a little more into what Deb's project is set up, which is the indistinguishable and the distinguishable couples, the same sex and different sex couples. I wanted to know how much more complicated it gets, or if you can use both the SEM and then the multi-level approaches if we kind of add this higher level. I think you talked about it a little bit of looking at the effects between couple types. So in Deb's project specifically being women with women, men with women, how much adding that almost 4th level does to, if you can, basically can you do it with both approaches, and how much does it overcomplicate things?
Yeah. I think you can do it with both approaches. It is another level, if you like, but it's not another random level, if that makes sense. It's not like these groups of couples are somehow sampled. I mean, it's not impossible to think of it that way, that there's other unions of people that we just haven't observed yet, and we're only observing the ones that we happen to come about. But you would normally think of those groups in a statistical sense as fixed effects. Like, in other words, I want to generalize what I have on these same-sex couples to all same-sex couples, and it's not, and that is just a straight generalization, and it's not something to do with. There's no random process in generating that group. We take that as not sampled, as a fixed characteristic. And so then in that case, you sort of have multi-group analyses. So there'll be a group for the heterosexual dyads. There'll be gay men, lesbians will be separate, and any other groups you might want. But those 3 make sense. And you can certainly, I mean, here's where I have a hard time with I know you can do it in multi-level modeling, but it is, see, it's very, multi-level modeling is just like having a single regression equation. It's a single equation method, and that is really so constraining in the end. So how do we handle the fact that there are multiple levels? We make just all these different rows that capture, like some rows are capturing all the data, all the time points on an individual. That's all these different rows. But now I have another set of rows that are these for a different individual. Well, those two individuals might be in a distinguishable dyad or non-distinguishable. So if somebody asked me to do that analysis, I would turn to JP. That's right, to SEM. In other words, I'm not recommending you do it in multi-level. But I would like to figure out how, but I honestly don't know how.
Yeah, I don't know how it would work with multi-level, but I think it would be multiple groups. I think you do a multiple group analysis in a 2-level model, basically. So like what we just did, except we would have multiple groups. I haven't done that yet, but that's what makes sense to me. And I think that's what I understand is possible in a package like M+.
Okay, perfect. Thank you.
Any other questions from the group here? Other questions on the Zoom chat?
No, we had a question about neuroticism, but apparently Marcy already had ESP. So
You read the group mind.
If no one has questions, I'd like to take the advantage of being a moderator here and ask you a question, if
Sure.
I may.
Yeah.
So I'm not trying to add in more complication here, but again, going with Michael, constantly thinking about our. Sorry.
For the online.
Okay, sorry.
Okay, so thinking about Michael, adding on to Michael's question, and also thinking again about our data that we are using. I'm sure we'll have more time to talk about this in the afternoon, but I think this would be I'm thinking that we might be adding another layer of analysis when we add like time there. So we have in terms of having multiple bursts of dyadic daily diary data that is collected from both indistinguishable and distinguishable dyads. So like how is it even possible to do it? Like is there a way to analyze such a complicated data? And like which approach would be like more desirable?
Well, I'm pretty sure that that's the multiple waves of diaries is, I think it's a great thing. It's not that common, but I would just think of it as another set of data lines that actually will sit in the data set right next, think of it right next to the previous set of diary data. And I would analyze them by having a dummy code that sort of distinguishes. Like, let's say there's just two, like 1 and 2. Well, you can imagine a dummy code that just says, here's the first set of diaries, here's the second set. Now imagine just having that as a variable that interacts with everything at the ordinary level. So imagine all the things you would do with a single set of diaries. So you would get random effects. So individual specific effects are possible then for each and every person in each and every dyad. And then the question of, is there a change in the daily process becomes an interaction effect between that dummy variable that's capturing the two waves and the daily process. I know I'm doing, I think I'm literally doing a lot of hand waving here, but it is, I actually think that's easier than you think. That part is easy. Because it doesn't bring in any new, yes, it's bringing new time variation, but you already have time variation in the data. So now it's a matter of, and now are the processes the same when you did this second wave, or are they similar? And if they're different, well, that dummy variable enables you to test for particular differences of. I know this is vague, but that's an easier problem than the problem of having a model that has no randomness at the individual level because it's saturated, because you've distinguished the two people and there's only two. You distinguish them. Now, if you don't distinguish them, now suddenly that's a estimable type of variation. And it's not uninteresting. I mean, it's very interesting. Even as a sort of an average over time, are people different on average within dyads? That's the person within dyad variation. And I would think for some things you will see big differences and other things not. You know, I mean, so it's everything is, like there's just lots of interesting things that now you can do. But that, to me, is a really big move, going from saying everything, sorry, I was going to say everything is fixed, but everything is accounted for in the model using a two-level model. That's, our whole careers have been based on using two-level models. And the reason they all made sense was that, you know, in a lot of questions that traditionally people were studying, you know, if you think of like problems that funding agencies care about, usually it's, you know, caregiver burden. Well, you know, that's not an indistinguishable dyad, or, you know, anything where there's a problem and there's somebody, you know, some focal person, so a teen suicide, teen, you know, and now you've got parents and teens. Well, you know, see, a lot of these questions are, you know, you're dealing with distinguishable dyads. So I feel like this issue, for me, hasn't really come up enough. And I think it's wonderful that it is, that we're at this point. And it's great that people are collecting data where this is just not an option. You really have to do this. You can't be shoehorning people into models that don't, well, I mean, it's just not possible. If you friendship dyads, that third level is there.
To get to your, another option, I think, to get to your question about adding in basically a second burst is, from an SEM framework, it's just another outcome. So it's another outcome that happens to be later in time, but it's another outcome. And so you could have code that processes, let's say, the stress reactivity example, you know, where stress at home, stress at work carrying over to home. You could have a stress reactivity coefficient for time one, for burst one, a stress reactivity coefficient for burst two, because you can analyze that as a separate set of outcomes. And then you could actually look at the difference between the two.
Yeah.
That difference is the same thing that the interaction effect would pick up.
In my way of thinking of it as stacked.
Right.
Whereas JP is thinking of making it wide. This is a very SEM kind of thing. Whereas, you know, multi-level models just have to put everybody into the same model, and everybody is just one long. And when you do measurement models, now you have something truly ridiculous, because now you have all the items have a separate data line for all the people, for all the bursts. And it's one, talk about a long form. That's about as long as you can get. Karen.
I wanted to let you know that there are comments in the chat saying that this was a phenomenal workshop, thanking you, Haiwan, and Rita, basically for organizing it too. So I just wanted to make sure that the chat people got to express their enthusiasm.
That's great. Thank you.
Yeah, this has been very, very well organized, absolutely. And I appreciate it.
Yes, me too.
I'm very glad to hear
relieved, actually, very relieved. That.
And I'm also glad that Deb, forced me to think about non-distinguishable dyads, because that's just a type of dyad that I've never worked with, but they're really important. And I think, we can't just say anymore, well, we don't really work with that, so I'm not going to answer that question. You know what I mean? So yeah, I mean, I think there's more to be said, but this forced us to move in that direction actually in a way that nothing else has actually.
Let us know if you want to experiment with the data.
Well, certainly, it is great to be pushed along these lines, because it is in the future, it's just it's a tool we need to have, and I think there'll be, I do think this person within dyad variability, if I can just keep using this term, I think that is going to be very interesting when we start to look at it, because it's completely hidden behind gender. And I don't think that gender is a super, I don't want to say that we should not be taking gender into account, but if we wanted to think about people as individuals, like rather than as representatives of males and females or whatever, then you have that option. I don't think it really makes sense for some data sets like the parents and the teens, although maybe that mightn't be too bad, because they are asked the same questions, and you can imagine pooling them and talk about, like, well, irrespective of whether it's the parent or the teen, when efficacy goes up, fruits and vegetables get consumed, and that's all good. I hope you all took the message, the hidden message here, to eat your fruits and vegetables. By the way, fried vegetables don't count. That's
potatoes.
Yeah. This is, by the way, these questions were developed by nutrition experts at the National Cancer Institute, so we do swear by them. The best measures of fruit and vegetable consumption on the market. We were using them.
And last one, you have to add in salsa.
Oh, salsa, okay.
Salsa, yes. Yeah, well, yeah.
Salsa is a vegetable. Yeah. Like ketchup. Yeah, I agree. Yeah.
Yeah. So I think we now all know that we need to eat vegetables, and I personally learned really a lot from the two panelists today, and so thank you both very, very much for your insightful comments, the presentations. I can express how thankful I am to be able to have this opportunity to invite you to here. So thank you for coming.
Our pleasure. Thanks. Yeah.
And thank you everyone on Zoom and here for coming around and asking great questions and making this discussion and workshop all more lively. So thank you. And again, if you have any questions, I want to point out that the slides and the recording of the video will be made available to everyone who registers. So we will send it to you shortly. And again, thank you all for coming. If you got more interest in intensive longitudinal data, these wonderful panelists have a great book on intensive longitudinal methods, so please check that out, and also keep a lookout for our future workshops as well. So thank you very much, everyone, and have a wonderful day. Thank you.